Okay, so here we go. This is day, well, I don't exactly remember which day we're on, but it's the first day of triangles area. Okay, so we know how to find the area of a triangle. We did that, and I did a preview of the different way. If you have the height, it's a piece of cake. This is 3, this is 2, and I can find the area as base times height divided by 2, right? 1/2 base times height. Need your full attention. So now, what if I don't have the height, though? Well, that's when that next formula came in. Let's say I have no height, but I have this is 8 and 8 and 6. Do you agree we could probably make a triangle look like that? Could we find the area of it? Sure. But you really, to do the medium hard way, you need an angle. Let's say I needed that angle right there, because I would have to go 1/2 AB. Do you remember it? Sine C. Now, in case you were one like somebody just mentioned in class, and I forget too, because this looks a lot like the law of cosines, and you might by accident think it was cosine, you'll be flipping a coin between sine and cosine if you have trouble with your memory. Here's a way to remember it. Only the law of cosines uses cosine. All the other ones are based on sine. Okay? So only the law of cosine uses cosines. All right. There is such thing as the law of tangents, actually. There is. But we're not teaching it to you. It's really complicated. Yes? Yep. Yes. That would always cut the base in half, and it would also always mean that these two angles are the same as each other. All good stuff to know. But what I need you to know right now is that if I was going to give this to you, I'd need to give you this angle, and let's say it's 50 degrees. You'd need that to be able to do 1/2 AB sine C. So how are you going to get that angle if I don't give it to you? Well, you can use law of what? Law of cosines. The law of sines is good is when you have an angle on the side across from it. If you have all three sides, remember the big triangle we had set up here? Remember how you measured all the sides and then used law of cosines? All right, I want you to do that again, except with no measuring. Just figure out that angle for me right there. If it's 8, 8, and 6, what would that angle be? Use the law of cosines to find that angle. That is not 1/2 AB sine C. That's what you'd do to find the area of it. I'm just asking for the angle right here. I'll pause for a second while you give that a try. Okay, so first up, a squared plus b squared minus 2ab. And let me think, is this the law of cosines? Because then I should use cosine. C equals c squared. And now I'm going to put in all the numbers. 8 squared is 64 plus 64 minus 2, stop talking, AB, which is, I'm going to use 8 and 6 for A and B. Okay, so that's 8 and 6. And I did something wrong already. Yeah, A and B are 8 and 6, so this will be 36. There we go. And then cosine C equals c squared. That's the c, and that's 64. Now, I'm going to choose to subtract 64 first. I know some of you wouldn't have, but I just did that because they're sitting out there, and I cancel both of them with one shot. And then I'm going to subtract 36 from both sides, and now I'll have a negative 36 over here. And now I will have negative, let me see, 12 times 8 is 80, 96, is that right? Cosine C. And then I have to divide by negative 96 on both sides. Does that come out to 1/3? No. 0.375. Okay, cosine of C equals 0.375. And then I'm going to take the inverse cosine on both sides and then help me with the final answer. What'd you get? 67.5 degrees. Raise your hand if you had that one the same. Uh-oh. 67.9? I probably just misheard. 67.9. How many would agree with 67.9? Okay, good. So then, if it was off, it was probably just rounding. So now the next part is, that's the angle. And after all that work, now you'd be ready to start finding the area. That's not super efficient, is it? So you do not want to try to find the area that way if they didn't give you an angle. So that's kind of the point, is what should you do if they don't give you an angle? Well, there's a cool formula for finding the area of a triangle where they don't give you the angle. Even though you can use law of cosines to get it, is pretty clunky. All right, final here was 67.9, so then I'd go, this is 67.9 degrees. Then I'd do 1/2 A, which will be 8, B, which will be 6, sine of 67.9 degrees. That would give me the area. Would you take just a moment and type that in and get the area so that we can know what the area is as we go into this next way? 42? 22 point what? 22.25. All right. That's, and again, off by rounding is no big deal. Okay, so that's units squared because it's an area. That's what we're doing here, is the area of this triangle. So what's the better way? Well, actually, I'm going to pause the video right now while I show a really cool method that or a video for how to get this formula that I don't have copyright privileges, and so therefore I can't put it in my video, but I will resume once we've got that formula. Okay, so that formula was the area of the circle. This is called Heron's formula, is the square root of the semi-perimeter, which is just half the perimeter. Notice I didn't average the sides. I added them all up and divided by 2, half the perimeter. And then I take the semi-perimeter minus A, one of the sides, S minus B, and S minus C. So here it is in action. Remember that one we did before where this was 8 and this was 8 and this was 6? Watch how quick this will be. Add these together. What do you get? 22. And then what's the semi-perimeter then? 11. So it's the square root of 11 times, and then I go 11 minus 8, which is what? 3. And then I go 11 minus 8 again, 3. And then I go 11 minus 6. And that is your answer. It's quick. You got to admit, compared to finding the cosine, or doing that cosine thing, the law of cosines, that took us like 10 minutes practically. This skips that whole process. You don't have to go find that angle. So, final answer, square root of some big number, and then what was the final answer? 22.25. Sound familiar? It's the same thing we got before, right? And in fact, the thing that's cool about this is, did we ever round this entire time? Not till the very end. Do you get that in the other one we had to round certain parts of our answer, making it further and further off? This one only rounds once at the very end. So that's another good thing about Heron's. Now, it's all about knowing when to use it. So let's go into your homework now and show you when you should use this versus when you should use that. Because it's like the right tool for the job. If I had to cut this table in half, I could do it with a drill. But it wouldn't be very smart. I could drill a gajillion holes and then finally it would break in half. Okay, that would be a really dumb way to do it because there's a right tool for the job. So when we get to our homework, if they got certain setups, like all the sides, Heron's rule is perfect. Heron's formula is awesome. Okay, so here's the first problem right here. And did they give me a good setup for Heron's? Nope, they didn't give me all the sides. So they gave me B, which I can pick anything I want to be B. I'll call this one 128. The longest one ought to be this one, 149. And then A, if this one was going to be C and this one was going to be B, that makes this little one A, and that makes this angle big A up there. Cool. But the problem with that is that, do you get the way it's labeled, I can't use 1/2 AB cosine C. Get what I'm saying? Sorry, 1/2 AB sine C. That's how you'd find the area of this guy, because I got an angle on 2 sides. But do you get just temporarily, I need to say that that's my C? I know that blows some of your minds, but do you get that it doesn't even really matter what letter's where? I don't care what letter's there, or there, or there, or there. do you get, if I have no letters at all and I can pick, which you can, I'm going to choose that this is going to be my angle C. I'm going to use this for A and this for B, and I can rearrange them. I don't even care what A and B are. And then I use this formula. Okay, this one's another one that they give you an angle and a couple sides. Again, not a great time for herons. Herons is used when you have all three sides. This one, it's got all three sides. No, wait, it doesn't. Still not a good time for herons. In fact, you can skip this one. I think we've had enough practice on the not heron ones, so skip that one. Moving on to this page. That's got all three sides, and that's going to be herons. Could you do it with law of cosines? Yeah, it just takes a long time. Herons is better for when you got all three sides. So I know these aren't very nice, but you can use a calculator. You add them all up, divide by 2, you get the semi-perimeter. And then from there it's easy. Square root of that, whatever that semi-perimeter is, and then you take the semi-perimeter minus A, and then minus B, then minus C. All right, then this one is also assigned. We've only skipped one so far. This one is assigned. It's more pre-calc-ish because it doesn't just ask you to use the formula. It says, here's the answer. So how long was this side then? You still use the formula, but you use it kind of backwards. That's a good one and important for you to know. And this last one, I will only skip one problem so far. And now we're about to skip the rest of the assignment from here. You may skip this one and the next one. So that's going to be a total of 3 pages got skipped. All right, now this one, just a hint. That one would have been the new formula called what's? Herons. This one would have been the 1/2 AB sine C. And then this last one would have been weird. You had to use a different one, and it's not law of cosines, and it's not 1/2 AB sine C, so law of sines. Because when the law of sines kicks in, you'll be able to figure out that, and then you can use 1/2 AB sine C. Anyway, but that you're skipping that page. I just wanted to show you that as an example. All right, that's all I got for you for today.